In this lecture, we'll be continuing our topic of springs and Hooke's law, and we'll be using a Java applet which is provided by phet.colorado.edu, and you will see how springs will differ when different masses are attached to them, and then we'll try to find out the extensions and the stiffness of the spring. So let's see. First of all, just a reminder to you that the Hooke's law states that force on a spring is directly proportional to the extension that it gives on. Alright, so this changes when we remove this proportionality sign. This becomes F is equals to K times extension, where K is the stiffness of the spring. Okay, yeah, here you go. This is the stiffness of the spring. So let's see an example here. We have three unloaded springs here. Alright, so this is the friction in the spring. There can be friction inside a spring, and if there is a lot of friction, the spring will not extend a lot. Let's see, these are the masses that we will be attaching, and these here, the colored ones, are the unknown masses, and we will find them out. Okay, but first of all, we have to find out the K of the spring, the stiffness of each of these springs. So let's find out what is the stiffness of the spring. Alright, so these are not of your concern, because here are some different things here. But let's just find out. Let's just attach a 100 gram mass here. Originally, when it was unloaded, you can see that the spring was somewhere here at this point. This was its original length, which is 20. This is 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So let me count it again. This is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. This is at 31 centimeters, original length of spring 1. We're talking about spring 1 right now. Original length of spring 1 was 31 centimeters. Now we are attaching a mass of 100 grams. And you know that 100 grams is simply 0.1 kilograms. You know the conversion. If you don't remember this, just watch the video on conversions, and you will understand how I've taken this as 0.1 kilograms, but it is 0.1 kilograms. So let's see, when I'm attaching a mass of 100 grams, eventually it's giving me an extension, and it will come to a point and come at rest. Let's see where it comes at rest. It comes at rest at the 40 centimeter mark. This is the new height of the spring when 100 gram mass is attached to it. So the new height of the spring, the new length of the spring is 40 centimeters. So what is the extension of the spring? The extension is simply new length minus the old length, or the original length. So new length is 40 minus original length is 31, which gives me 9 centimeters. The extension is 9 centimeters. Remember that our SI unit is meters, kilograms, newtons, because the mass is in grams, and I had to change it into kilograms, into the SI unit. And for this, I will have to change it into the SI unit of length, which is meters. This will become 0.09 meters. Alright, so this is the scenario. This is the mass, and this is the distance, the extension. Now our formula of Hooke's law says F is equals to K times extension. Now we know the mass, but what is the force that the mass is applying? So we know whenever something is hanging onto something, it is the gravitational force that acts on that object, and that is sole force. So we know the mass. Let's find out the force associated with this mass, and that is given by, that force is simply the gravitational force, which is also called as weight, which is mass times gravitational acceleration. So this becomes 0.1 times the gravitational acceleration on Earth is 10 times 10. So the force becomes 1 Newton on the spring. So you can see for 1 Newton, the extension is 0.09 meters. Alright? So let's find out the stiffness of this spring, of spring 1. So stiffness of spring 1 could be found out very easily, because we know the force, which is 1 Newton. We know the extension, which is 0.09 meters. So the formula is F is equals to KE. Just make this K the subject. This would become K is equals to F divided by E. In this case, this would become F would be 1 divided by 0.09, which would be something about, let's say, approximately, if I don't have a calculator right now, but approximately about 10 or 11, something like that, 10 or 11 newtons per meter. This would be the extension of the spring, the stiffness of spring 1. So to find out the stiffness, now this stiffness will remain constant no matter what mass I attach, whatever I attach, we know the value, and you can calculate this value easily. You'll find out the answer. So this is the stiffness of spring 1, and now once you've found this out, once you have calculated this value, this will remain constant. All right. Now let's find out the stiffness of spring 2. Stiffness of spring 2, and also stiffness of spring 3. Same way. In this case, let's just attach this 100 grams mass here. The original length was 31 centimeters. It was on all of these on the same point. So this also extends to 40 centimeters. So again, for stiffness, the original length was 31 centimeters. The new length is 40 centimeters. The extension would still be 41 minus 31 30 centimeters. Sorry, 40 minus 31 centimeters. This would give me 0.09 meters of extension for 1 Newton of mass. So this means again the stiffness of spring 2 is again 1 over 0.09, which is again about 10 to 11 newtons per meter. This tells me that the spring spring 1 and spring 2 are made up of the same material, because their stiffness is the same. They're made up. If spring 1 is made up of iron, spring 2 is also made up of iron. All right. That is the stiffness. Tells me stiffness is an internal property, and it is different for each of for different materials. So if two springs have the same stiffness, that means they are made of the same material. Now let's see. Let's find. This is originally at 31 again. Let's find this out. Alright, so again it's coming on 40, which means stiffness of spring 3 is also 1 over 0.09, because again the extension for 1 Newton is 0.09. So it will also be 10 or 11 newtons per meter. So this will again tell me that all three of them are made of the same material, because the stiffness is the same. Now that we know the stiffness of all three of the springs, we can attach any mass, and depending on the extension, I can find out let's say the mass, the unknown mass. Let's see. Let's do first example here. the extension of spring 1, I know, sorry, the stiffness of spring 1 is 1 over 0.09. Alright, so let's see. Let's attach a mass of 250 grams. Alright, and we will see what the extension is. I am attaching a mass of 250 grams. My mass is 250 grams, which if I convert to kilograms would become 0.25 kilograms. Now what is the force associated with this mass? The force associated is given by mass times acceleration of gravity, which is g. So 0.25 times 10. The force is 2.5 newtons. This is the force associated with this. Alright, now the original length is 31 centimeters. Alright, now if I know the stiffness of the spring, the formula is F is equals to K times E. I know this value because I've calculated this, and this does not change. It will be constant for a spring. It will be constant. So let's find out the extension if I attach this mass. If I attach, let's say this is 2.5 is equals to 1 over 0.09. Right? So extension is simply 2.5 times 0.09. So this will give me a value of, let's say 2.5 times this, let's assume this is 0.1, and the value would be around 0.25 approximately. I'm just approximating because I don't have a calculator here. So I'm approximating that the value is 0.25 meters. The extension is 0.25 meters. Alright, so let's convert this into centimeters. Just multiply this with 100. So this would give me 25 centimeters. Approximately 25 centimeters. Alright, now let's find out the new length of this thing. The original length was this, it extended to 25 centimeters more than this. This would be 31 plus 25, which is a 56 centimeters. The new length would be 56 centimeters. Now my scale only extends to, let's say, let me just keep it here. Alright, and we'll find out the extension of this first spring. The new length should be 56 centimeters. So let's just attach it here, and our extension was about 25 centimeters. So let's just see the extension when this mass was attached. So you can see the spring is approximately at 25 centimeters, 25, 24 centimeters. This is 20, 21, 22, 23, 24, 25, and because I didn't use a calculator, I got a value of 25, approximated a value of 25, and it's roundabout very close to that value. So we are correct. Physics is working, guys. So this is one of the examples. We'll be talking more on this Java applet, and we'll see how we can calculate almost everything about this spring in the next videos. Thanks for watching.